Hello and welcome to today's video, and congratulations on making it to the last video of the Unit 1 and 2 series. Today we are talking about transmission and spread of disease. So let's kick it off. Here's our learning goals. First up, we will recognize that the transmission of disease is facilitated by regional and global movement. We'll also identify different factors that can spread disease, so we'll look at transmission and proportions of populations as well as immunizations. We'll analyze these factors to predict potential outbreaks, as well as look at different control strategies that there are in preventing the spread of disease. These include personal measures as well as community level measures. We'll make decisions and justify them, but this is going to be done in class, as well as interpreting data. Again, done in class. So if you pause the video here and just write your own version of these learning goals down in your books. Okay, so moving on. First up, let's look at movement of organisms and how this can lead to transmission of disease. To begin with, I'm going to play you guys a video. So this is from a movie that you may recognize, and it's got a pretty cool credit scene. Let's check it out. So this credit scene is from the movie Rise of the Planet of the Apes, and it came out in 2011. And basically what we're seeing here is they called it the simian flu, and it's this genetically modified virus that was created in the lab, and it was found to increase intelligence in apes, but they learned that it mutates rapidly and is untested on humans. And if you've seen the movie or know the series, you would know that it is this virus that causes apes to become extremely intelligent, but also leads to the downfall of humanity and therefore the rising of the apes. And as we're seeing in the background here, these lines just represent how quickly a virus can spread through global movement of organisms. And that is what this learning goal is all about. We're going to talk about how pandemics spread. To begin with though, it's helpful to define a few terms. So you've probably heard of an epidemic or a pandemic, but maybe you don't know what the difference is. So let's talk about that. Essentially, an epidemic is more of a localized spread of some kind of virus within a community, whereas a pandemic is something that goes global. We're going to talk a little more about that on the next slide. But what I want to focus on for now is talking about just the spread of viruses amongst organisms. So we live in an interconnected and increasingly globalized world. So thanks to international jet travel, People and the diseases that they carry can be in any city on the planet within a matter of hours. So once a virus touches down, sometimes all it takes is one sneeze, one interaction, to spread the virus throughout an entire community. I'm talking viruses, but we can talk kind of any infections. And with the invention of agriculture in the last few 100,000 years, people began living in more localized areas as opposed to just moving from area to area. And people would start living side by side, as well as with animals. And animals, we have seen, also facilitate the spread of viruses and bacteria. And when viruses go from animals to humans, that's when we can see they can get really nasty. So today, planes can transport viruses and other infections around the globe in a fraction of the time that they used to be able to spread previously. Normally, it would be by boat. We saw like the Spanish flu after the wartime, it would be spread by soldiers by boat, which still did the job, but it was a lot slower. As globalization increases, so does the spread of diseases. For example, in 2003, there was a Chinese doctor who arrived in a hotel in Hong Kong, and he was just feeling unwell. Unknown to him, he was harboring a new animal origin virus called SARS, which is short for severe acute respiratory syndrome. And this is also related to the current COVID virus. Within 24 hours, 16 other guests had been infected, 5 boarded planes to overseas destinations, spreading to multiple other countries within hours. But thanks to our emergency response and endeavors, our pandemic was averted. Pandemics have always been associated with panic. However, science gives us the ability to recognize pandemics early and to take measures to minimize their impact. And that's what we're going to talk about a little later in this video. What measures do we have in place? So this learning goal was just to recognize that movement of organisms is a big factor in transmission of disease. So, moving on. Let's talk about factors that affect the spread. So the rate of transmission is not constant and varies with different disease, populations, and time. However, there are several recognizable patterns. So I'll pull up this image, and if you have a look at that, we can see over time we're talking cases of illness, and there's big spikes and little spikes, and so we have different classifications for that. So epidemics occur when there is an increase in the number of cases of a disease within a population to above what is considered normal. If the epidemic spreads across multiple continents throughout the world, it is called a pandemic. And so that is something that isn't represented on here, but it's when what we're seeing here just goes big. The mechanism of transmission of disease strongly affects how a pathogen can spread. So some modes of transmission restrict how a disease spreads to a particular, say, climate or geographical location. For example, malaria. It's spread by the vector of the mosquito, and so therefore it's restricted to where that mosquito lives, such as South America, Africa, and Asia. And these are areas that are close to the equator, whereas influenza can exist throughout the world as it is spread through droplets and it's not dependent on a vector. Transmission is also affected by a pathogen's, keyword, infectivity. That's its ability to spread, as opposed to what we've spoken about before, virulence, which is the pathogen's ability to cause severe disease. So you can have something that's extremely virulent, it can cause a lot of, it's very potent, harmful, but it might not spread, it might not be very infective. So the persistence of pathogens also affects the spread of disease. For example, some pathogens can stay around in asymptomatic carriers. That means they've got it, but they're not showing any symptoms, and it can still be spread to others. For example, maybe you've heard of typhoid. It was traced back to a single person. It was a cook. Her name was Mary Mallon, who was asymptomatic, but she still spread the disease to many others, and so got this nickname called Typhoid Mary. The spread of disease is also affected by the proportion of those who are immune. Reducing the number of those susceptible to a disease is the basis of immunization. Immunization historically has substantially reduced worldwide morbidity and mortality. And I'll pull up this image here. This just shows how we have prevented a number of different diseases in the world, even though it's just talking about America, through vaccines. So vaccines at this point in time are very controversial, but we can look at vaccines from the past and see how they have been affected. For example, diphtheria, there's been a 100% reduction in cases and death. Similar with measles and mumps and pertussis, which is also known as whooping cough. Polio has literally been eradicated, and these are different diseases that have just ravaged children populations, and we can see through vaccines we can just create this immunity in a community, and therefore it just acts as this barrier. People who are no longer susceptible become a wall and protect those who are susceptible, maybe those who can't take a vaccine, because not everyone can. Some people get really sick. For example, the elderly can be more susceptible to vaccines, but also it's an ethical choice, and not everyone chooses to take a vaccine. So that's why we see in the media currently that for a vaccine to be really effective at a community level, there needs to be a high percentage of those who are immunized, and it generally depends on the infectivity of that particular disease, generally around the 70 to 80% mark. So the spread of disease is affected by the proportion of those who are immune. Immunization programs have the ability not just to prevent the spread, but to also eradicate diseases, like I said, such as in the case of polio. Polio is a crippling and potentially deadly infectious disease that is caused by the poliovirus. And the virus spreads from person to person and can invade an infected person's brain, and is still a threat in some countries today. Again, smallpox, there's an image in your textbook of this. It was eliminated with the vaccine in 1980. It's this flu-like disease. Lastly, the mobility of individuals into unaffected populations can also be a major factor that spreads a disease. So contact to unexposed communities can be devastating, as they have had no previous exposure and thus immunity. For example, the colonization of Australia by the Europeans introduced a number of crippling diseases such as smallpox, influenza, typhoid, and measles to previously isolated populations of Indigenous Australians, and it just ravaged these populations. So there's a number of different factors that can affect the spread, and we've talked about persistence of pathogens within a host. So that being, if someone is asymptomatic but they can still carry it, that can really affect a lot of other people. Transmission of mechanisms, so we spoke about, for example, how is something spread? Is it through droplets or is it through a mosquito? And how does this therefore affect who it can reach or at what time of the year? And then we spoke about the proportion of a population that is immune, and basically that whole idea was called herd immunity, as well as mobility of individuals in an affected population. So that could be For example, how the Europeans colonized Australia. These are factors that affect the spread of disease. We can also talk about how natural changes can affect the spread of disease. So, for example, if we have a change in temperature in an environment, or the building of dams and irrigation networks where we create these bodies of water, this can lead to outbreaks in waterborne vector diseases, such as malaria. Mosquitoes breed in wet areas. Not only that, but extreme events such as tsunamis or cyclones or floods or fire can lead to breakdown in community hygiene measures, and therefore mass displacement of people, which can lead to outbreaks of often diarrheal diseases such as cholera or typhoid or hepatitis, as waste can often infect or trickle into the water that people are drinking. And we often see this in countries where there are earthquakes or tsunamis, that hygiene measures are just broken down and people get really sick through that whole event. So that is the idea of these. And if we can look at potential outbreaks, if we talk about these factors, so if we see that there was a natural disaster, we can often predict a potential outbreak, or if we see that there's these bodies of water that are being produced, we might look at malaria or different vector-based diseases that are spread through vectors that require water to breed, or we can look at the different temperature. We see, for example, influenza. It spreads from the northern hemisphere to the southern hemisphere, to the northern hemisphere to the southern hemisphere, because it's more spread and persistent in cooler environments. So this is, again, just summing up factors affecting spread. So let's move on. Strategies to control the spread of disease. Now, I've shown you this video in class, and I'm not going to play the whole thing, but this video here,
in this way, my mother got well and
is an excellent video that just shows how different personal as well as community-based measures can really stop the spread of a disease. So if you haven't seen it, I'll put the link in the description as well for you to check out. But essentially, strategies to prevent potential outbreaks include personal and community level decisions and actions. It's important that health organizations are continually monitoring and evaluating which strategies are most effective towards the relevant outbreak as well. So we're talking hand washing, and how this is so important for everyone, especially healthcare workers. Other personal hygiene measures just include staying home when ill, covering the mouth when sneezing or coughing, not touching the face, and keeping a distance from infected individuals or when you yourself are infected. We've seen more recently how important contract tracing is in, say, a person is deemed as infective, then we look back at all their recent contacts to be able to see who could be potentially infected but don't even know it yet. Once someone is found to be infectious, quarantine is a highly effective measure. This is also used for travel and animals that are imported into the country. We can also do things at a community level, such as closing schools and workplaces. But then this poses another challenge: is where do those people go when their school is closed? Are they going to congregate in other public areas? We've seen that this can be effective in the very early stages of an outbreak. But reducing mass gatherings, research has shown that it's not extremely effective as compared to other well-known strategies, such as simply covering sneezes, wearing masks, washing hands, sterilizing door handles. We also have infrared thermal image scanners, which they just create an image, and different colors indicate different temperatures. And if someone has a higher temperature than normal, then that could indicate a fever, and that indicates they're sick. And this can be used at airports, but even these have their limitations, because someone who is sick can simply take Panadol and bring that fever down, but still spread whatever it is they have. But then we could talk about travel restrictions, and we've seen with COVID that there was major restrictions that came into play, and this has had a really big effect on minimizing the spread of a disease. And a particular study showed that the Wuhan measures, where they closed their borders and we closed our borders in response to the outbreak of COVID, that cases reported internationally were reduced by 70 to 80% as opposed to what they could have been. So travel measures can be really effective and important in managing the spread of disease as well. So, moving on. Homework. As always, if you jump on to your textbook, that is chapter 16, and it is the last chapter for Unit 1 and 2. Please read that and add keywords to your glossary. I hope that this video has been helpful, informative, and basically it's just a summary to everything we've spoken about in class, as well as a summary to your readings. But one last thing I have to say, and that is, congratulations, you have made it to the last video of the Unit 1 and 2 series. And this is extremely special for our Year 12s who have studied Unit 3, studied Unit 4, studied 1, and now have completed 2. You have done such a good job, guys, and I'm so proud of you. So you deserve to enjoy this moment and to celebrate. And Year 11s, I'm proud of you as well. I look forward to this moment with you guys next year, where we can just look back and again celebrate the journey in biology it has been. So with all that being said, I wish you guys the very best with your study. I hope that these videos are helpful for you to go back and watch. I hope that the resources that I'm giving you in class are also an awesome strategy for revision. But with all that being said, exams and grades aside, I hope that biology has been an interesting and an engaging course for you. And I wish you all the very best with your final examination. God bless. I shall see you guys in class.